Hello guys, today we're going to look at a couple of examples from section 1.6. We're going to look at number 15 and number 22. One thing I want to point out is that I've given you guys a summary for section 1.6, and it's a nice little Word document with all of the parent functions in one place, and then all of the rules are summarized down here. So definitely pull up this document, print it out if you want to have it. I think it'll be really helpful. Okay, so let's look at the problem. So it says use the graph of y equals f of x, meaning just this graph here, to graph the function g of x equals 2 times f of 1/2 x. So we have to pay attention to what's going on in here and whether or not it's happening inside the function or outside the function. So we would say this 1/2 is inside the function because it's in the parentheses, and the 2 is on the outside of the function because it's outside the f of x. And that makes a difference in terms of our rules. So if we go to our rules here, okay, a constant being multiplied on the outside of the function is a vertical stretch or shrink. A constant being multiplied on the inside of the function is a horizontal stretch or shrink. So you see how the constant's on the outside versus the constant's on the inside. Okay, that's the difference. Now if we look at our example, we actually have one of each. We have a constant on the outside and a constant on the inside. So we're going to have to do both. So our note sheet says, the constant on the outside, we're going to multiply the y value by the constant because it's going to stretch it vertically. It's going to stretch it up and down. And the constant on the inside means we're going to divide the x value by the constant. So you got to pay attention to these rules because you got to do the right thing. So we're going to multiply the y value by 2, and we're going to divide the x value by 1/2. The other thing I want to point out, when you're talking about vertical stretching and shrinking, if c is greater than 1, that's a stretch. If c is between 0 and 1, that's a shrink. But when you're talking about horizontal stretching and shrinking, it's actually the opposite. Okay, so c between 0 and 1 on the inside is a horizontal stretch. So what we have in our example, the 2 is a vertical stretch. The 1/2 is a horizontal stretch. Okay, so this picture should stretch vertically and horizontally. Okay, so that kind of makes me think it might be B, but we will check. We're going to get some points to make sure. We don't want to just guess. So right now, the points that we have, okay, if I make a table, whoops, with the points that we have -4, -5, -2, -3, 0, -1, 2, -1, and 4, -3. So using this, I can close that now. I'm going to do my vertical stretch and my horizontal stretch. Okay, so for the vertical stretch, that's the 2 on the outside, we're going to multiply all the y values by 2. Multiply the y values by whatever number is on the outside. So -10, -6, -2, -2, -3. For the horizontal component, we're going to divide divide the x values by 1/2. Well, here's the funny thing about dividing by 1/2. It's the same thing as multiplying by 2. I'll kind of do it over here to the side real quick. If we take the first one, -4 divided by 1/2. When you divide by a fraction, you're really going to multiply by the reciprocal. That's a rule for dividing fractions. So it ends up being -4 times 2, so -8. You can also do this in your calculator. That's not a problem. So all of these get multiplied by 2 because we're dividing by 1/2. Once I have my new points, I just have to pick the graph that has those points. And since I know that's a vertical stretch and that's a horizontal stretch, we're going to check B first because I'm pretty sure that's what B is doing. So I have -8, -10, that's good, -4, -6, yep, zeros at -2, 4, -2, and 8. Ooh, I made a mistake, you guys. That I forgot to change. That should be -6. That was my bad. My bad. 8, -6. I forgot to do that point. So the answer is B, okay? Now we could tell that anyway because we knew this was a vertical stretch and this was a horizontal stretch, and that's what this picture did compared to this one. Again, and that's based off of the rules in this document here. Okay, so moving on to number 22. Oops. Number 22. Oh, no, I didn't check. Okay, there we go. Now number 22. Okay, so this one's not a multiple choice, and that's why I wanted to do this one. And we have several things going on in our equation here. So we're going to start with f of x equals x squared, and we're going to graph -2 x minus 6 squared plus 4. Now x squared is one of our parent functions. If we go up here, x squared makes a parabola, a U shape. Okay, so we already know this is going to be a U shape. Okay, if we make a table for x squared kind of as a starting point, that sometimes can help because then we'll just do it the way we did the last problem by changing the values in the table. So I always start with some negatives and then some positives because again they didn't give us a graph to go off of, so we could really do whatever points we want, but it's just easy to do some negatives, 0, and some positives. So to figure out the y values, all I'm doing is plugging them in for x, right? So -2 squared is 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. So that is the original function, okay? The original function. Then we have to do all of these transformations. Now, when there's multiple transformations, there is an order to it that we need to use. So down here at the bottom, it's horizontal shifting, then stretching or shrinking, then reflecting, and then vertical shifting. Okay, so we have to keep that in mind. We got to go in that order. So the first thing's horizontal shifting. Well, this -6 on the inside is the horizontal shift. If we go to our rules, a minus a constant on the inside moves the graph right C units. So we need to move right 6 units. So I'll do a new table. Now we have to think about it. If I move right 6 units, what is that going to change on my points? Does that change the x value or does that change the y value? Right 6 should change the x value because you're moving right. That's moving along the x direction. So all of these x values are going to move right 6. So that becomes 4, 5, 6, 7, and 8. I'm adding 6 to all of my x values. My y values wouldn't change because all I did was move right. I didn't move up or down yet. The next thing that we need to do according to our order here is horizontal or stretching and shrinking, either horizontal or vertical. You gotta do all of it. So what we have is a vertical stretch right here with the 2 on the outside. So when we do vertical stretching, we're multiplying the y value by the constant. Okay, so this is for the vertical stretch. So I'm going to do the same table, and now I'm multiplying the y value by 2. My x value is not going to change for this one. So all the y values multiply by 2. Okay. Then we have to do our reflecting. Okay, we do have a reflection in this one. The negative out front means it reflects over the x-axis, okay, over the x-axis. So any point that's up here would reflect to down here. Any point that's down here would reflect to up here. So what's changing with that reflection? If I'm going from, say I'm up here at +6, I would reflect down to -6. So it's my y value that's changing, okay? So then we'll do one down here. This will be reflecting over the x-axis, and that's going to change my y value. Reflecting over the x-axis changes my y value. So all of my y values are going to change signs because they're flipping upside down. Sorry, my dogs are being loud again. All right, last thing, we're almost done. We got to do this up 4. That's always last. Up 4. Okay, because that's on the outside. That means it's up or down. And it's positive, so that's up 4. So up 4 also changes the y values. They're all going to go up 4. So I have to add 4 to all my y values. So my x values, again, are not changing. My y value is going up 4. Make sure I do this correctly. Up 4. Ooh, okay. All right, so we started with a parabola that was in the center, kind of like this. Okay, so now we've got a whole new set of points. It's gone right 6, it's been stretched vertically, it's reflected, and it's gone up 4. So now we're kind of somewhere like over here. That's a really bad picture, but we will see it when we do it on here. Okay, so we gotta do this real. Actually, I'm gonna need to make a second video because my timer's gonna run out. Hold on 1 minute.